Welcome to Math 096, Lecture 27. First off, welcome back from spring break. And then secondly, Lecture 27 is a continuation of the material we covered in Section 5.1. So if you haven't already looked at Lecture 26 and worked through the related material, you want to stop this video, go check out Lecture 26, and then come back. So today we're going to continue on with section 5.1, and we're going to be starting here with example 6. The directions for example 6, simplify. And we have a problem 35 x to the 4th, y to the 12th, divided by 15 x to the 9th, y to the 9th. Now, as you look at this problem, if you're not certain how to start, what I would suggest is that instead of looking at this as a big problem, break it down and think about it as 3 smaller problems. So notice that we have constants at the beginning of each one of the numerator and the denominator pieces. So let's go ahead and think about those as a separate smaller problem. So we have 35 divided by 15. And then we can do the same thing with other pieces in this problem that look alike. So we can go ahead and say the x pieces are going to be a separate fraction, x to the 4th divided by x to the 9th, and the y pieces can be a separate fraction as well, y to the 12th divided by y to the 9th. Now, as you move forward with this section, you might not need to write down that separate step where you're thinking about each one of these individual fractions, but if it's helpful to you, go ahead and do it. So now that we have those smaller fractions, it's a matter of simplifying each one of them. So 35 over 15 is just number ideas in terms of fractions, and you want to reduce your fraction as much as possible. Notice that 35 and 15, they both end in a 5, so at a minimum, I know that they're going to share a factor of 5. So let's cancel a 5 out of both of those. If I cancel a 5 from a 35, I'm going to be down to a 7. And if I cancel a 5 from a 15, I'm going to be down to a 3. At this point, I have 7 over 3, and there isn't anything else that's going to cancel out of those pieces. So now let's go ahead and check out the next fraction. We have x to the 4th divided by x to the 9th. Now, we have 2 different ways of thinking about this problem. We can think about it in terms of the quotient rule, or we can think about it in terms of cancellation for fractions. Now, what I said last time was that for problems that have the higher power in the denominator, the quotient rule, we don't really have all the techniques necessary to finish that yet. So I'm going to go ahead and choose on this one to think about it in terms of simply fraction ideas and canceling common factors. So I have 4 copies of the x in the numerator. I have 9 copies of the x in the denominator. That means that I have 4 copies that I can cancel in both places. So if I cancel 4 copies of the x from the numerator, I'm going to be down to the number 1. And if I cancel 4 of the 9 copies out of the denominator, we're going to be down to 5 of those copies. And then, as you look at the last fraction, y to the 12th divided by y to the 9th, once again, we can either think about it as cancellation or we can use the quotient rule. On this one, I'm going to go ahead and choose to use the quotient rule. So y to the 12th divided by y to the 9th, the higher power is in the numerator, and that's why I'm choosing to use the quotient rule. So remember, the quotient rule says if you have y to a power divided by y to a power, you can subtract those exponents. 12 minus 9 is 3. So this is going to be y to the 3rd. So now that I have all of that information, I can put all the pieces and parts together. I have a 7 times a 1 times a y to the 3rd in the numerator. That's going to be 7y to the 3rd. And in the denominator, I have 3 times x to the 5th times 1 over here. That's going to be 3x to the 5th. So we have 3x to the 5th. And there's our final answer. 7y to the 3rd divided by 3x to the 5th.